So now we are going to start with the property that is the ionization energy. As you all are very much familiar that we know that the metals have actually tendency to lose electrons, and whenever we want to extract an electron, suppose this is my atom, these are my shells, and suppose this is my outer shell, and I need to remove an electron from this shell, right. So I can definitely remove it, but for removing I need to supply energy from outside, and that energy is something called as ionization energy, right. So that means we need to supply ionization energy from outside, then only the electron will get removed. So that energy is ionization energy, that is the energy required to remove most loosely bound electron from outermost shell of an atom. So as now we are going to look for the trend that we are just going to compare the ionization energy among the transition metals along period, along group, and also from the S block also. So if we compare the ionization energy from the S block, what we have seen there, because in the S block there is filling of S1 in the first one group, another it is S2, and in the third what do we see, that there is a filling of S2 along with d orbital, right, and 1, 2, 3, 4 so on. So that means this is going, because it is bigger in size and there is less nuclear charge, so that means the less ionization energy is required to remove the electron, right. So if we compare this and this, the first S group and the second S group, it is comparatively smaller because due to increase in nuclear charge, as there is more electron. So more electron means more proton obviously, and there will be increased nuclear charge. So therefore the size decrease and the ionization of this one is higher as compared to this. Now coming on to the d orbitals, d block elements, we see that compared to this they will have somewhat higher ionization energy. The reason being because there is an increase in electron, so that means nuclear charge increases, and therefore the ionization energy increases as there is decrease in the size of the atom. So if we compare it with S block, so definitely they are going to possess the higher ionization energy because there the nuclear charge, the number of electrons are more and the nuclear charge is more, therefore the size is small and therefore the ionization energy is more. Now we will see that how it varies along the d block elements, along period, how it varies among the d block. So we see that among period, when we see, I just let us take an example of first transition series. So it is 4s2 3d1, 4s2 3d2, 4s2 3d3. So this kind of trend you get to see here. So what happened actually, that you see that when you move from this place to this place, there is increase in the electron. There is increase in the electron, and as the electron increases, so that means the proton also increases, so that means there is an increase in the nuclear charge, right. So ionization is somewhat more, in this case the ionization is high as compared to it. But what we see, that progressive filling of d orbital, here d has 1, here d has 2, 3, 4, 5, 6, 7. So due to filling of d orbital, we know that like as more and more electrons will add up to the d orbital, there will be more screening effect. So that means when we are moving along period, the nuclear charge is also increasing due to addition of proton, and there is also increase in the screening effect due to addition of due to filling of the d orbital. So that means out of this nuclear charge and screening effect, what is there? These d orbital electrons are actually that they are screening the valence electrons. So that means they are not letting the exact nuclear charge to reach to the outermost shell electron. So due to which there will be definitely increase in the ionization energy, but the decrease will be the increase will be very low. And what is the reason? The screening effect is the reason, right. I think you got it. So if somebody is going to ask you that how ionization energy will vary along period, you are going to say that when we move in the transition series, there is progressive filling of the electron, right. So that means there is an increase in the nuclear charge, right. But due to filling of electrons in the d orbital which have the shielding effect, screening effect, so that means the screening effect is also increasing. And here when we compare the nuclear charge and the screening effect, there is a pronounced effect of the shielding effect, that is the screening effect. So that means the outermost electron is not tightly bounded by the nucleus, and we have to supply, definitely we need to supply the energy to take out electron, but that energy is comparatively low. So that means as we move along the period, the ionization energy is increasing, but the increase is not a marked increase, there is a slow increase in the ionization energy due to the shielding effect. Now if we consider an example of chromium and copper. In chromium we know that the configuration is something 4s1 3d5, and in copper it is 4s1 3d10. Right. So because they are half filled actually, and we know that half filled and fully filled orbitals are more stable. So due to this the ionization energy is very high. But we can actually remove one electron from this shell, but when we remove this electron then it gets the extra stability, and after that the ionization energy becomes very high, right. So due to the extra stability of half filled and fully filled orbitals, they have actually the high ionization energy. And if we talk about copper, nickel, zinc and all, so they cannot let more electrons to be lose actually, again due to their high ionization energy. Now if we compare the ionization energy of the third transition series with the second transition series, so let us take an example. Suppose this is my second series and this is my third series. In second series there is, we know that in first there is a filling of 4s and 3d, in second there is a filling of 5s and 4d, in the third there is a filling of 6s and 4f and 5d. So what happens if we compare the this thing transition series, the ionization energies of the second and the third transition series. So if we compare that, we know that the third transition series actually should have the low ionization energy, it should have the low ionization energy. But what happens actually when we compare the second and the third one, in the third there is a filling of 4f orbital also, there is a filling of 4f orbital, and due to this filling of 4f orbitals we know that they have actually a very poor screening effect, and because they have very poor screening effect, so that means they are not letting the nuclear charge to reach the valence electrons. So that means again we will see an example again. See, in the second series what we have, there is a filling of 5s and 4d, and in the third there is a filling of 6s, 4f and 5d. So what is the difference between the second and the third? That is the filling of f orbital. So do you think that out of s, p, d and f which has the maximum shielding effect? I told you in a previous lecture that s has the maximum and f has the least screening effect. So that means it is not you can say succeeding in shielding the valence electrons, and as it is failing in doing that, so that means the outer shell electrons are tightly bound by the nucleus, and when they are tightly bound by the nucleus, this confirms that actually the ionization energy is high. So otherwise if somebody talk to you that when we move down the group, we know that the ionization energy particularly decrease because there is increase in the size. But here what is happening here in this case, that the second transition series has actually the less energy, the third has the less energy as compared to the second. The reason being because when we are moving, there is a filling of 4f orbital in the third series, and due to filling of that 4f orbitals, we know that it has the poor shielding effect, and that due to this poor shielding effect, the nucleus you can say that is attracting its valence shell electrons with a greater force, and when there is a greater force, that means the ionization energy is comparatively high. So this is what is the ionization energy. I think you got it. So if somebody is going to ask you about that, so what you need to do is you need to define it, that what actually it is, and then you need to compare with the S block, because here we have the S block and this side we have the P block, and then is the long period, how it varies along transition elements. There you need to focus on the configuration. So as we know, half filled and fully filled orbitals have extra stability, so that means obviously their ionization energy is going to be higher. And if we consider copper and chromium, again the extra stability, So here also you will consider the same factor, and the ionization energy will be comparatively very high in this case. And when we compare this second and third transition series, so that means due to progressive filling of the 4f orbital, that is the poor shielding effect. So obviously the ionization energy is going to be more for the third as compared to the second. So this is what is the ionization energy.